Alright, welcome to this lesson on computing the average rate of change over a given interval on a graph. Now, this very first one is the only one I'll do this and put you through this on. But let's look at this. If we were trying to compute a rate of change on the graph f of x, okay, and f of x is the graph x squared. So if I were to graph that, if I put 0 into the function, I get 0. 0 squared is 0. If I put 1 into the function, 1 squared is 1. If I put 2, 2 squared is 4. And if I put in 3, 3 squared is 9. Okay, so basically we have the point 0, 0, the point 1, 1, the point 2, 4, and hopefully this next one will fit 3, 9. Okay, this is just one side of our parabola. The other side would be symmetric to that, so it would look the same. Now, they're asking us to find the average rate of change on the interval from 0 to 3. So from x being 0 to x being 3. If we start where x is 0 and end where x is 3, what is the rate of change? Or in some cases, they might call that the slope. So if we were to draw a line through those 2 points, what's the slope of that line is basically what they're asking us. Now, if we analyze that line, we can see the slope is about up 1 over 3, about 3. Now, the way that we find the slope, remember, is you would take the 2 points, okay, being the starting point was at 0, 0, and the ending point was at 3, 9. And to compute slope, we do y minus y over x minus x. Hopefully that's something that we would remember. Okay, now for this function, that would give us 9 minus 0 for our y's, 3 minus 0 for our x's, and we get 9/3 or 3 as the average rate of change or the slope. Now the formula they use for this, so that you don't have to draw out a graph, is that they use, I believe this is it, f of b minus f of a over b minus a, and this is the rate of change over the interval from a to b. Okay, still kind of weird looking, I know. So all you're going to do is compute the function for your 2 endpoints, okay? So we're going to say, okay, if x equals 0, what's our function equal to? Our function was 0 squared would be 0. If x equals 3, what would our function be? Well, 3 squared is 9. And what you do is you take the results, 9 minus 0. On the top of your fraction, on the bottom, you put the x values that gave you those responses, so 3 minus 0. And again, we get 9 over 3, or 3. So this is the formula we're going to be using. Okay, you compute the function for each of the endpoints, put those on the top and subtract them. On the bottom, one thing that's important is make sure that the b's are lined up and the a's are lined up. You can't flip-flop them, or it will affect your answer. Now let's try another one without all of this extra stuff on our screen. Okay, so here is our function now, is that f of x equals x plus 2 over x minus 1. They want us to compute the average rate of change over the interval from 3 to 5. Okay, so again, what we're going to do is we're going to do f of 5 minus f of 3, and put that over 5 minus 3. Okay, so first what we have to do is we have to find f of 5, and we have to find what f of 3 is. So we plug those into our function, x plus 2 over x minus 1. So here we have 5 plus 2 is 7. 5 minus 1 is 4. So we get 7/4 for f of 5. f of 3, we would have 3 plus 2 over 3 minus 1, giving us 5/2. If we put this information into our formula up here, okay, we're supposed to do f of 5 minus f of 3 over 5 minus 3. Well, our f of 5 was 7/4. Our f of 3 was 5/2 over 5 minus 3. Well, the 5 minus 3 is fairly straightforward. 5 minus 3 is 2. On the top, fractions sometimes give people trouble. You can use your calculator, or you can recall that we have to have a common denominator of 4. So if I multiply this fraction by 2, that gives me 10/4. So I have now 7/4 minus 10/4, and I can subtract them now. 7 minus 10 gives me negative 3/4 all over 2. So what do we do with that? Again, you can use your calculator and do negative 3/4 divided by 2, or you can recall that this would be 2 over 1, and to divide fractions we invert or flip the second fraction and multiply. So that gives us negative 3/4 times 1/2, or negative 3/8. So having fractions in that one complicated it a bit more, but we did go through the same basic steps. We found f of 5 and we found f of 3. Okay, evaluated them in the function. So then we took those two values, f of 5 minus f of 3 in the numerator, and then just plain 5 minus 3 in the denominator. And then from there you just have to be able to simplify. And we got an answer of negative 3/8 when it was all said and done. Hey, let's try one more of these. Hopefully this one will be a little less fraction oriented. Okay, we've been given a new function here. Our function is 2x squared minus x plus 1. They want us to compute the average rate of change over the interval from negative 2 to 1. Okay, so we go ahead and our formula would tell us to do f of 1 minus f of negative 2 and put that over 1 minus negative 2. Let's try that out. Our first job is to find out what f of 1 and what f of negative 2, what those values are. If we compute f of 1 for 2x squared minus x plus 1, we get 2 times 1 squared minus 1 plus 1. We evaluate that. That gives us 2 times 1 squared is 1, minus 1 plus 1, 2 minus 1 plus 1, just gives us plain old 2. Now let's compute f of negative 2. You want to be very careful with your parentheses here. That gives us 2 times negative 2 squared minus negative 2 plus 1. If we calculate that, we get 2 times negative 2 squared is a positive 4. Negative times negative 2 gives us a plus 2, and plus 1. 2 times 4 is 8. So we end up with 8 plus 2 plus 1, which gives us 11. Okay, we've computed f of 1 and we've computed f of negative 2, so we know the functions at their endpoints. We know the y values. We just put that into our function here. F of 1 was 2 minus f of negative 2 was 11 all over 1 minus negative 2. Notice minus a negative down here would make that a plus in the end. So we get 2 minus 1 is negative 9. I'm writing the answer down early. And 1 plus 2 is 3. Negative 9 divided by 3 is negative 3. So the rate of change for 2x squared minus x plus 1 over the interval of negative 2 to 1, the rate of change is negative 3.